Alrighty, so in yesterday's video, we have a composition of functions. Here, number one, given functions f and g, so two functions given, we have f of x is 3x plus 2, and g of x is a half x. So we have two functions. What they want us to do is, for part A, if h of x, a new function, is defined by the composition of functions of g composed of f of x, so this little open circle, we're talking about a composition, not multiplication, right? Composed, we would read it as g composed of f of the original input x. We want to find h of this input. So still dealing with evaluating functions. Now, the only difference is that we're dealing with the evaluation portion to be some sort of composition. So with the composition, I'm going to set it up first in terms of function h. So if I take this function h, input 2b plus 3 into the function, its rule would be g composed of f, but my input is 2b plus 3. Right? So if I want to write its statement to what this h of x changes to. With composition of functions, we start with the function that is closest to the input. So here's my input. The function that is closest to that input is function f. So I start with the f function, input this 2b plus 3 into function f. So function f, 3x plus 2, evaluating functions, 3 times the input plus 2. Go ahead and do your distribution, combining like terms. 3 times 2, 6. B, I hate sixes and b's together. It just happened. I didn't notice that. Got to change that number. 3 times 3, 9. We got this plus 2. So we end up with 6b plus 11, right? We input into the function that's closest to the input. We get an output. Now this output becomes the new input for the next function, the g function. So we're taking this 6b plus 11 and inputting it now into the g function. G function, 1/2 times the input, 6b plus 11. I'm going to mesh this together or distribute the 1/2. Let's distribute. 1/2 times 6b, that would be 6b over 2, which is equivalent to 3b. Distribute 1/2 to 11, just gives me 11 over 2. So final output for the composition H of input 2b plus 3 is equal to that. Let me move that closer. Why is this so far? And let's box it. So composition of functions, we start with the function that is closest to the input. We get an output. That output becomes the input for the next function. And we keep doing that if we have multiple functions, right? We work our way to the last function. All right, let's do number 2, or letter B. Letter B, we have h of x is defined using different notation, f composed of g of x. So we still have a function inside another function. That's what composition means. You have a function inside another function and so forth. So we're dealing with a composition. We want to find h of a minus 1. For this given rule, that would be f composed of g of that a minus 1. Just like before, we start with the function that is closest to the input, in this case, g. We look at g's rule. G is 1/2 x, so 1/2 a minus 1. I'm going to distribute that 1/2 to everything inside the parentheses, giving me 1/2 a minus 1/2, right? Okay, so we get an output, whatever that output is. Sometimes it's nice, sometimes it's not the nicest. What we're going to do now is take this output that we got for the g function, and we're going to input it into the f function, the next function. The f function, what's this rule again? 3x plus 2. So we got 3 times this input plus 2. Again, the output from the previous section is my new input for the next part. Again, we are going to distribute this 3 to everything. We get 3 over 2a minus 3 over 2, and we have plus 2. What we want to do is combine like terms. We want to combine these terms. So we have our function h. When we input a minus 1, we get a 3/2 a, and this one was a positive, right? I believe it was positive, yes. Positive 1/2.